Welcome back. So example 4 is pretty much the same thing that we did in example 3. So if you wanted to try it on or try it on your own, you can. I will say though, like I mentioned before, the zeros, you can find them. We've talked about how to find zeros. You're going to get a special kind of answer, which will mean on your graph it's going to look a little differently. But if you want to try it on your own, you can. And if you kind of get stuck on the zeros part and you want to watch me do it, then you can do that, or maybe you can figure it out. All right, but otherwise, let's get started. So, the first step is we're going to find the axis of symmetry, which the axis of symmetry, the equation is x equals h. And remember, h is the number that is added or subtracted to the x value. And remember, you have to think the opposite with the h value. You have to flip the sign. So since this is a plus 1 in my equation, that means my axis of symmetry is going to be at x equals the opposite of that, which is negative 1. Okay, so this will be a vertical line that hits the x-axis at negative 1. So I'm going to go ahead and draw in my vertical line. Here's my axis of symmetry. Okay. And technically, if you wanted to label the other parts on the previous example, you could. I forgot to label the x-intercepts and the y-intercepts. So on your previous example, if you wanted to label those, you can. Sorry, I just forgot that I did that. Okay, but anyway, so we have our axis of symmetry. The vertex point, we know the h value is negative 1. The k value is whatever's added or subtracted to the end, and you don't flip the sign on that one. So that is going to be a negative 2. Okay, so my vertex is at the point negative 1, negative 2. And again, you guys see that I have landed on the axis of symmetry. The vertex should always be on the axis of symmetry. Okay, the a value is the number at the very front that is right in front of the parenthesis or right after the equal sign, which in this case, it is a negative 2. Which means my a value is negative, so it's less than 0. And since it's a negative graph, it's a sad graph, so it has a sad face. Okay, so that means we're going to have a maximum when we graph this. So it's going to be facing kind of downward when we graph it. Okay, the way we find the y-intercept, we're going to make x 0. The way we find the x-intercepts is we're going to make the y 0. And then we're just going to solve. So you just simply solve after you replace either x or y with 0. Okay, and don't forget, you guys, the only time you can say the y-intercept is whatever's on the end is when you're in standard form. Okay, if you guys noticed from the previous problem, the number on the end was negative 4, but my y-intercept was 5. So just be careful. The only time the y-intercept is the number on the very end is when you're in standard form. So be careful. Okay? So in order to find the y-intercept, I have to transform all of my x's into a 0. Okay, so I'm going to replace my 1x right here with the 0. So I'm going to have y equals negative 2 times x, which will now transform into a 0. And then plus 1 squared minus 2. Okay, so don't forget, you guys, when you do order of operations, you got to do parentheses and exponents first before you multiply. So I'm going to deal with the parentheses first, then the exponent, then with the multiplication. Don't forget, you guys, there's secretly multiplication in between the negative 2 and the parentheses, so be careful. Okay, so we have y equals negative 2 times 0 plus 1. Well, that is going to be 1. And then that will be squared minus 2. So don't forget, you guys, we do exponents before we multiply. Okay, so do not do negative 2 times 1 and then square that. We're going to do 1 squared, then times negative 2. So be careful. The demon cats are always out to get you. All right, so we have negative 2 times 1 squared. 1 times 1 is 1, minus 2. Okay, so negative 2 times 1 is negative 2. And then we're going to bring on down this minus 2. And -2 minus 2 more is -4. So my y-intercept is where y is -4, which is the point 0, -4. Okay, so my y-intercept is at 0, -4. So 0, 1, 2, 3, 4. And now I can reflect it over the x-axis. So my y-intercept is one space away from my axis of symmetry. So that means when I reflect it over, it'll be one space to the left of my axis of symmetry. So that will be one space over here. Look at that. Okay, we're getting close, you guys. The last step is to find the zeros, which remember, that's the same thing as your x-intercepts. So I'm going to make y equal to 0. So I'm going to change this y right here to a 0 and then solve for x. And don't forget, since we have a squared in the problem, that means eventually we're going to have to take a square root, which means we're using the square root property. Okay, so let's go. So my y is now going to transform into a 0. So my y is now a 0 equals -2 times x plus 1 squared, then minus 2. Okay, let's solve this thing for x. So the first thing we're going to do is move the -2 over to the other side, which the way you do that is by adding it on both sides. So I'm going to add 2 on both sides. -2 plus 2 will cancel and turn to 0. 0 plus 2 is 2. So I have 2 equals -2 times x plus 1 squared. Like that. And my screen froze. There we go. Thank you, screen. Okay, now before I can deal with this x plus 1 squared, I need to move this -2 to the other side, which -2 is secretly multiplying to the parenthesis. So the way that you move that to the other side of the equation is by dividing it on both sides. Which -2 divided by -2 will cancel and turn to 1. 2 divided by -2 is -1. Okay, so we're left with -1 equals x plus 1 squared. Okay, now I'm going to bring this up here. I'm going to flip around my equation because I prefer my x to be on the left side when I solve. I'm sorry, I'm being really picky, but that's just how I like to do it. So I'm just going to flip around my equation. So I'm going to have x plus 1 squared equals -1. Okay, you guys are getting really close to solving for x, but currently the squared is getting in the way. How do you undo a squared? Or what is the inverse of a square? Square root. So I'm going to square root on both sides of the equation. Okay, so the square root will cancel out the squared. So you're left with the x plus 1. Now don't forget, you guys, when you square root both sides of an equation, what appears on the right-hand side of the equation? A plus or minus. Nice job, you guys. Okay, so we're going to have plus or minus. Now I have the square root of a -1. So first of all, when you have a negative under your square root, remember, an I will hop out. So I'm going to have an I, and then the square root of 1 is 1. So this is like 1I or I. And if you guys remember, I equals the square root of -1. So this whole thing right here is just I. Okay, and then the last step to get x by itself, I'm going to bring the positive 1 over, which the way I do that is by subtracting it on both sides. So 1 minus 1 will cancel and turn to 0. Now remember, you guys, most people will put the plus or minus after the number. Okay, so I'm going to write it like -1 plus or minus I. So we're going to have x equals -1 plus or minus I. Okay, so one time will be x equals -1 plus I. The second time will be x equals -1 minus the I. So you can write it like that. Like you could say x equals -1 plus I, or x equals -1 minus the I. So you can also write it like that. So if you guys see here, we ended up with imaginary or complex solutions. So these are complex solutions. Guys, and you cannot see imaginary or complex numbers on a real number system graph. It just doesn't happen. This graph only shows real numbers. Okay, so if you ever end up with imaginary numbers, that means your graph is just simply not going to cross the x-axis. Okay, it will never cross it at all. Okay, so if you guys see here, when I connect my points on my graph, they look like this. And if you guys see here, the graph is headed downwards, and if you see, it never crossed the x-axis. Holy hot dog, right? I know. So if you guys ever end up with imaginary or complex solutions, just know your graph is never going to smack or cross the x-axis. So it'll either be hovering below the x-axis like this, or it'll be hovering above the x-axis facing upward. Okay, so just remember that if you end up with those types of solutions, it'll either be above the x-axis or below, and it will never cross the x-axis. All right, well, doesn't that graph look wonderful? I think it does, and I think it deserves a name. This graph to me looks like an Ingrid, so I'm going to name it Ingrid. Well, there you guys have it. We've learned how to graph in standard form. We've learned how to graph in factored form, and now we've learned how to graph in vertex form. You know 3 ways now how to graph from a quadratic equation. Isn't that really neat? I know. Well, nice job, you guys. You should give yourself a pat on the back because that was some wonderful work. Excellent job, you guys.